scope deliverable development. So the next part of philosophy is why do an estimate? Again, this is high level. There are many reasons, but here's some of the predominant reasons for developing an estimate. To manage budgets, determine return on investment, select the most economical alternative, and primarily, what we're going to focus on today is to enable the business to make sound financial decisions. So let's talk about what is an estimate. Now, these are some dictionary definitions: a rough approximate calculation to form an approximate judgment regarding the value, worth, or magnitude of a fill in the blank. Determine rough size or extent of nature of a project, or even software development when it comes to that. But today's discussion, we're going to focus on TIC, Total Installed Cost Estimate, which captures all the costs required for a project from inception to completion. So next, we're going to talk about what an estimate is not. As my friend Dilbert, here's a day in the life of an estimator portrayed by Dilbert and Company. I need a budget estimate for my project, but I don't have a scope or a design for it yet. Okay, my estimate is $3,583,729, but you don't know anything about my project. That makes two of us. So I love Dilbert. The best comedy is rooted in everyday life events. That's why Dilbert is so popular in our industry. And if you're an estimator or in BD, you've lived this moment potentially many times. Oh, by the way, this is not a credible estimate. So the next topic is, how long has estimating been around? So to answer this question, let's talk a little bit about parables. A parable is a story which illustrates a moral. So, for example, the boy who cried wolf. For a parable to accomplish its goal, the elements of the story must be familiar to the audience. So let's take a look at the example on the screen. Suppose someone wants to build a tower. Once you first sit down and estimate the cost to see if you have enough money to complete it. Or if you lay the foundation and are not able to finish it, everyone who sees it will ridicule you, saying this person began to build but was unable to finish. Now, these days, our towers are a little more sophisticated than in the culture when this parable was initially given. And I would say these days, the results of a project that ends poorly would go beyond ridicule. There have been project managers who may have had to move on because of the result of their project. But the point of this slide is that this parable is approximately 2,000 years old. And since the use of the term estimate in the parable would have been well known at the culture in that time, that means that estimating predated this parable. So therefore, we know that estimating has been around for more than 2,000 years. And also, this parable is project methodology in a nutshell. So we're going to move on to the business case for FEL, or front-end loading. Now, what is FEL? Why do FEL? How much FEL? Can I skip FEL? Those are all really good questions. Let's talk a little bit about that. Our industry uses many terms for FEL, such as pre-project planning, or PPP, front-end engineering design, or FEED, or simply basic engineering. But in essence, FEL is a gated process for project development to ensure that business objectives are achieved with minimal investment. I like to use the house building example because it is very commonly known, to most people. So if you're going to build a house, you know how much money you make, and you've developed the budget for how much you can afford, and you're going to finance it, and what your monthly payment's going to be. So how much is the house going to cost? So you come up with a scope in your head, you and your spouse or whatever the case may be. How many bedrooms, how many bathrooms, how big of a carport, do you want a porch, do you want a swimming pool? Those are scope elements for building a house. And if you've never built a house before, you're going to talk to somebody who has a pretty good idea of what it costs to build a house. Now, from a conversation, just you telling them how many bedrooms, how many bathrooms, they'll be able to give you a ballpark estimate, but it's only going to be based on square footage. And of course, where in the country you're going to build this house, they will adjust the dollars per square foot. Now, that number that the couple or the individual takes back to go do economic evaluations on is not a number that's good enough. It may be credible, but it's still not good enough to bring to a bank. So if a bank's going to lend you, let's say, $250,000 to build this house, they're going to need something a little more than a guy you talk to, his say-so, or a number that he wrote on a sticky note one day, okay? So if you're going to go to a bank to finance a house, you're going to have a floor plan. And the bank will actually do an assessment of what they think the value of that house is before they're going to lend you the money. We do exactly the same thing. It's a lot bigger than a house. Most projects have multiple zeros behind that initial three numbers, and it's all about project development. So in the first example, there was no cost involved. They found somebody, the person wanting to build a house found somebody that they knew, and they had a discussion. Could have been a credible number. It's just that it's not good enough to go to a business to get an allocation of funds to go do that project. So very little investment in the first number, and then to build to draw house plans, or in our case, you'd want P&IDs and a plot plan and an equipment list. Then you can go to the next phase gate of FEL. So how much money or time do you need to spend in FEL? So I'll give you an example. There was a Baton Rouge chemical plant that converted several of their units. They had a DCS conversion. It took more than 3 years, 1,100 approval signatures, and over 50% of the total project cost was support. So in other words, the owner cost of their SMEs being involved, their project management, their construction management, et cetera, plus the engineering. Now, the reason they spent so much time and money on the FEL of this project is it was going to be a hot cutover, and they were going to save money in the long run because they weren't going to have to take an outage. And the primary driver of that project was to not trip the plant. And they didn't want to see that flare go off, okay? So that's an example of extreme FEL, but there was a reason for it, all right? I'll give you another example on the other extreme. Is it okay to skip FEL? I worked on a project. It was a Texas client. They spent $1.1 million scoping a project and estimating that project that was never built, because in the final analysis, the economic evaluations showed that they could not afford to do the project. There wasn't enough return on investment. Now, what happened was the client project manager decided to skip FEL and go straight into doing a funding grade estimate. Well, it takes more time and money to develop a 10% TIC than a lower grade TIC. So halfway through the effort, somebody else from the organization stepped in and said, you're spending too much time and money, let's back up, we need to do a 30% estimate. So there were several 30% estimates that were done. They de-scoped, the first one was way too much money. They de-scoped it, did it again, and never did a 10% estimate because the business would not support the project. So those are kind of some bookends of, good FEL. The project was completed successfully within their budget. It was expensive to do the FEL, but it paid off. The other example is they spent a lot of money doing FEL, but if they'd have done it in the right steps, doing the lower accuracy estimates first, they could have saved a lot of money to come up with the answer of, we can't afford to do this project. Okay, so now we're going to see what FEL looks like. Now this is a busy slide, and I don't want you to get bogged down into the details. What I want you to focus on is that top arrow, increasing estimate quality and accuracy. Okay, so there are many different, what this illustrates is that there are many different terms. If you look at the bottom, there are alternate estimate names and conventions commonly or currently in use. You'll see that some people say FEL, some people use the term class, some people call it a level, some people just use names, some people use grades. Sometimes the numbers go from high to low. In some cases, the numbers go from low to high. So, when we do estimates for clients that have different terminology as they define their gated processes, I always find it better to kind of focus on the accuracy of the estimate that you need or you're looking for. So no matter what you call it, they all say the same thing. The more information you know about building your house or building the plant, the more accurate your estimate's going to be. So how do we determine the maturity of a project? Well, one way is you can look at, and the next slide is going to be a grid of estimating deliverables for the increased accuracy as the project information is developed. So this is a CDI estimating guide, and you'll see on the left the disciplines, and on the right the description of the deliverables. Now again, it's kind of busy, and we're not going to drill down to this level of all these different deliverables, but I want you to look at the color-coded columns and the X's. The far right is a 10% funding grade estimate, and you'll see that all of those deliverables are marked with an X, which means they are required. So it's the highest degree of accuracy. It also requires the highest degree of supporting documents to support that estimate. So if you back off to the left, you'll see the screening column, and much fewer of the deliverables are required to generate a lower accuracy estimate. And the purpose is you spend less time and money generating that estimate, and you get a number that you can do economic evaluations on to determine if it's worth investing in more time and money to go to the next phase of project development. Now one example of how this can be used is, a client can come in and say, here's how much money the business has given me to investigate and develop a scope for this project. So what level of accuracy can you give me? So we can kind of back into the dollar figure and how many deliverables we think we can deliver or develop for that budget, and then we can see which one of these columns it fits into and determine what accuracy can be given. The other way is a client says, I need X accuracy, I have Y budget, I have a Z time frame. And then we can go generate the deliverables or proposal for those deliverables and then generate the estimate. The question then is, well, what if this request comes in and the budget or the time frame are not enough to generate that level of accuracy. So that kind of generates a little bit of a dilemma for an estimator, because we're wanting to generate a TIC with a stated accuracy, and we want it to be credible. And so if we aren't going to have the deliverables to support that, it's going to take a little bit of negotiating and heartburn on the estimator's part. But I'll say that we've very successfully been able to navigate through that situation. And in some cases, the published TIC did not meet the original accuracy of what the client project manager had requested. And I can say that when we went to the review with the business was very grateful to CDI for giving them an accurate assessment of where this project was in its development. So it all boils down to integrity. As I gave in the house building example, just because you have a number on a piece of paper and that number is credible, it still may not be accurate enough for a business to allocate the funds to do the project. So the estimator must be well grounded in the correlation between the deliverables and the accuracy in order to explain or defend the need to spend the time and the money for the scope development. Okay, so now we're going to move on to estimating tools. All right. So we use a variety of tools. Aspen Capital Cost Estimator is our primary production platform. Aspen In-Plant Cost Estimator is a smaller tool, same family for smaller projects. We use Excel. We use Chemical Engineering Plant Cost Index. We use updated cost indexing within our tool, and we have a strong estimating work process. As you can imagine, when it comes to estimating tools, things have changed quite a bit over the last 40 years. When I did my first estimate when I was 16 years old. I was painting houses, and my dad would do the estimates, and then he was in the hospital one time, and what are we going to do? And he said, well, you've seen me estimate painting houses before, you go estimate it. So I did, and it turned out successful, and I don't know, I guess the rest is history. But over the last 4 decades, started off with paper and pencil, and for a time we used Lotus, and then when Excel came along, that was awesome. You could be consistent, you could put formulas in there, you could save templates. It was just awesome. Now we use this ACCE as the industry's leading cost engine, and it's a very, very powerful tool, especially for early on order of magnitude estimates for large chemical and petrochemical facilities. So how does ACCE work? So it has hundreds of equipment cost models, and you can put the throughput of a vessel, a pump or a tank or a tower, and it'll return a reasonable cost for that piece of equipment. But it also generates volumetric costs for the bulks, the foundation, the piping, the instrumentation, the electrical, the insulation, on and on. So like I said, it's very powerful for early on estimates. Now, as we progress to more accurate estimates, we substitute better definition from the project team, and we will substitute those quantities and size characteristics for the bulks to get a better cost. So there are also interactive graphic P&IDs. So when you put the cost model in, the P&IDs that are attached, you can open that up and click on a line, and it will show you the size that it's calculating for a pipe, how long it is, the wall thickness, whether it's insulated or not, and you can click on it and you can change those parameters based on better information that you may have. Now, the cost engine, it's not a database where you have to have a huge catalog of, prices for every 2-inch, what's the cost for a piece of 2-inch pipe or a 2-inch elbow. It has a cost engine, which is a mathematical formula that follows a sliding scale. So when you change the size of a pipe, it moves that price point on that calculation and returns a dollar figure. That's pretty accurate. Also, the Code of Accounts, which is the COA, which is the Code of Accounts, can be indexed to a particular project or for the market. So the next topic is the estimating process. Consistency is very important when it comes to, especially when you have team estimating, which is required for a large project. So we'll take a large project scope and we'll split it up between multiple estimators. They'll generate their own files, put their takeoffs and inputs in, and then we'll combine all that and roll it into one estimate. And so because of that, we just need some consistency in the terminology, the way the components are built, so that when we pull that thing all together, you get one good homogeneous estimate at the end. The next thing we do is perform a peer review and management review of the TIC before we publish it to make sure that the processes have been followed. And then the TIC estimate is easy to read and understand, and it facilitates easy client review and validation. Now, this last bullet is very important. If the TIC doesn't obtain joint ownership, and by that I mean, obviously CDI is going to claim ownership of that TIC when we develop it and when we publish it. If the client doesn't understand or agree with the dollar figure, it could be ignored or discarded, and that would be a terrible waste of time and effort. So it's important that the client is able to review and understand the estimate and, frankly, believe or buy into that is a credible number, and yes, we think that's what it's going to cost, so that when they do their economic evaluations, they can come up with a good business decision. Now, one thing I didn't put as a bullet, but almost step one in the estimating process, is to hire top shelf estimators. We have an excellent team of experienced estimators on our team. We have specialists in I&E, in mechanical, and in civil steel. So those are the key elements of the estimating process. So to recap, the project, this is how to obtain a credible estimate. First, the project team and the estimator must know the business objectives that the project is to accomplish. The project definition deliverables must be adequate to support a requested TIC accuracy. The estimating tool must be up to date with current market conditions. The estimating processes must be rigorous enough to ensure estimate completeness. And the estimating presentation must be easy to understand, and client validation is required. The key is this bullet right here. Project definition deliverables must be adequate to support the requested accuracy. You've heard the old saying, garbage in, garbage out. Well, without proper FEL, The other bullets on this slide are absolutely irrelevant. So with that, I'm going to open it up for questions. That's in a nutshell what I had. I'd be glad to entertain any questions.
Thank you, Marty. Just a reminder, you can unmute your line by hitting *6. It looks like we got a couple questions in the chat box. The first one for you, Marty, is how much does a TIC estimate cost to produce, and how long does it take to produce?
Well, that's a loaded question. But let me start by saying that in general, PL, in terms of a percentage of TIC. Now I know, it's always difficult when you're starting out and you don't know what the TIC is going to be, but you got to start somewhere, and somebody's got an idea of what this project's going to cost because they've done some very early on, economic evaluations, and they know how much money they're going to be able to make off of the project, and they know what they can afford to spend as an investment to get that return. So if you have an idea, ballpark of what you think the TIC is going to be, let's just start with, say, an FEL2 or a 30% estimate. Now, this is not just the estimating effort, okay? Hopefully I've demonstrated that, you have to have the accompanying deliverables to support that estimate. Now, those deliverables can be client generated, but CDI can also generate those deliverables, to be used by the estimator. But anyway, so the whole effort of developing the deliverables and the TIC for a 30% estimate could be less than 1% of the TIC, or as much as 3% of the TIC. Now, moving on to, say, for example, an FEL3 or a 10% estimate, the cost to develop that could be less than 3% of your TIC, or it could be, it could be up to 5% of the TIC, based on the nature of the project and the size of the project, and how many iterations and how many options you want to consider. But that's kind of a ballpark. And then the corollary with the cost is also the time. Typically, you would spend more time generating deliverables for a 10% than a 30%, as correlation to the cost. And that one would be a little more difficult for me to put some bookends on. Very large 10% estimates, the FEL phase could be months, whereas a small 30% estimate, the FEL could be weeks. Hopefully that would answer that question for you.
Thanks, Marty. The next question, how do you know your material costs are current with the market?
Okay, so one of the bullets I touched on in the presentation was our indexable code of accounts. So let me give you an example. Say structural steel. The estimating tool breaks down the structural steel discipline into many different elements, like handrail with toe plate, or grading, or main structural members, stairs, ladders. All those things have specific code of accounts, and each of those code of accounts can be indexed to tweak the unit dollar up or down. So what we do on a regular basis, typically it's annually, sometimes it can be semi-annually, we'll take say a 10% estimate definition package of, it'll have the steel defined with sketches and the member sizes, and say it's 100 tons of steel. We'll take that package, that 100 tons of steel package, and send it out to 3 vendors, and take their quotes back, and then condition those quotes, and then index our code of accounts so that our tool returns the same dollars as the vendor quote. And in that way, we keep all of our material costs up to date with the current market.
Thanks, Marty. Next question, what happens at impasse between the CDI estimating market-based parameters and the client's own cost numbers?
That's a good question. Typically, we default to or defer to client parameters. We do estimates for lots of different clients, not just in the U.S. Gulf Coast, but internationally as well. And so different clients have, I'll give you an example of proratables, okay? Some clients that have large projects which will be installed during an outage have different terms, but one of the terms used is proratables. And basically, it is a layer of owner management to install that project during a turnaround to make sure that the turnaround gets the focus, not the particular capital project. So the turnaround management team manages all of the maintenance activities, all of the multiple capital projects that are being installed during that turnaround, and their turnaround management team is primarily responsible for making sure that that turnaround is completed successfully with no safety incidences, no environmental incidences. They stay in budget and is completed on time. And so they're managing a lot of different projects, and the cost for that management team is divided up and allocated to each of the different capital projects. So there's no way for CDI to know what that budget needs to be. So we would defer to the client, and that's just one example of, now we stay in tune with that, and we put a budget for that turnaround management in the TIC estimate, but it's much better to have a client input for that number rather than CDI generating that budget. And there are many other examples, construction management, the client project management. Different clients handle that differently. Some clients have a site budget that manages the capital project installation, and that budget or that resource wouldn't necessarily charge the project. So CDI has U.S. Gulf Coast rates for labor and productivity that we use as a default unless we have better input from the client, which we would prefer to use.
Thanks, Marty. Please explain what is meant by the level of scope definition on the slide showing the different estimate classes and align with the definition completeness in AACS cost estimate clarification matrix.
Well, that's a very good question. And depending on what resource you use, which defines the required deliverables, AACE has a 35-page document describing the different levels of estimate and the corresponding deliverables. And then they also give a huge, in my opinion, range of accuracy for a particular level of estimate. So the best way to come to an agreement between all parties of a project team is to have an interactive discussion about the project, the specific elements of the project and the nature of the project, using those deliverables, the narrative in those deliverables as a guide, and seeing which ones are available or applicable, and then what documentation is available, and more importantly, what level of documentation is available. So, for an example, if we talk about P&IDs, okay? Now, somebody can, you can have a process engineer or a piping discipline for that matter, generate a P&ID that's redline and shows some instruments on it and the major equipment. Well, technically, it's a P&ID. But what level is that P&ID? And does it have enough information like line sizing and pipe spec? And does it show all of the instrumentation? Does it show insulation or tracing? So those are the kinds of nuances that you get into of, well, this piece of paper says I need a P&ID. Well, here's your P&ID. Okay, yes, it does, but it is a P&ID, but it may not be to the level or the pass of quality of deliverable needed to support a 10% estimate. So that is going to be a early on step that needs to be taken, that needs to be interactive between the engineering side and the client side, using a deliverables guide and working through each of those categories of deliverables to determine what is going to be required for a required accuracy.
Thanks, Marty. And another question we got in was, how do you use Chemical Engineering Plant Cost Index?
So that's a magazine that is published monthly, and in the back of it is an index, and they collect data on completed projects throughout the United States, and its index started, I believe, back in the 40s. It was set at 100, and so each year that projects are completed, they benchmark those completed project costs against that index of 100, and they report what the chemical plant index is for the month and the quarter, and then for the end of the year. And that takes them about 3 months. The report is about 3 months lag, because it takes them that long to collect all the data. All right, so that's the background of what the index is. And the way it's used is for these very, very early high-level estimates of, hey, I built a plant. It was commissioned in 2010. And so if you know the year it was completed, the dollars it cost for that plant, and the nameplate, the throughput, the nameplate of the throughput for that plant, and you're considering building another plant that makes that same product, then you can use a 6/10 rule to scale it up and down, and then you can look at the chemical plant index to see what the historical cost increase has, or decrease in some cases, has been, to come up with a very early ballpark number to generate a TIC to go do your very early economic evaluations.
Another question we got in, Marty, does your software generate indirect costs, say, for example, owners, project management, construction management, capitalized interest, etc.?
So the answer is yes. ACCE has the capability of generating those budgets. What we have elected to do is use ACCE to for the early on projects, then yes, we would use the tool to generate all of those numbers. But in the 30% and 10% estimates, we use the tool to generate field direct costs, and we drop that in from the tool into Excel, and then we would manually produce those project indirect costs. We have a better feel for, and our Excel summary template has some formulas in there where we can do a better job of calculating capitalized interest, owner costs, things of that nature, based on our knowledge of and understanding of the client's site.
It looks like we've covered all of our questions. Marty, is there anything else you wanted to cover before we wrap up?
No, I think that's it. I appreciate everybody's time and attention, and I think that's it.
Great. Thank you, everyone. We appreciate you being here. We'll upload this webinar on our YouTube channel. We'll also forward out the slide deck and Marty's information to those who joined us today. If you would like a PDH certificate for your attendance today, please send me an email or reply to the email invitation and let me know. Thanks again, and we'll see y'all next time.
Thank you, Laura. Thank you, Marty.